everyone, we are here to present about a research study entitled The Revolutionary Thermoelectric Charger Using Light Bulb Heat on Smartphones.
The first thing we will report is all about the chapter 3, which is the materials and methods. The first thing that we will do is to gather the materials. The light bulb will be bought in any near hardware or local stores. The Peltier module TEC1-12709 will be bought from the internet. The wires needed and the Sanwa tester will be provided by one of the researchers, while the USB plug will be bought from any technology shop.
Of the device. The researcher will put light bulb on one side of the Peltier by using a tape so that the device will keep in place while the experiment is going on. The light bulb will be lit by attaching wires between the big dry cells and the bulb. After that, the wires of the Peltier will be connected to the USB plug wherein the phones will be charged.
Next thing we will do after preparing the device is testing it. The smartphone that is of low battery will be plugged in the USB port. The light bulb will be lit so that it can produce energy. The light bulb used is 12 volts so that it can generally create 37 degrees Celsius to 40 degrees Celsius, which makes the Peltier generate more energy.
Data analysis. After making the setup, the researcher will use the Sanwa tester to check the amount of volts that the light bulb is creating and how it affects the battery of the cell phone. The researchers will wait until the phone acquired its fully charged state.
The researchers decided that the research design to be used is single group design. It is because the experiment is an invention and the tests will be conducted on different people. The research will not need a control group or an experimental group because the research is an invention.
Results and discussion. The researchers performed an experiment to determine the effectiveness of thermoelectric charger to charge a certain smartphone with the help of the light bulb heat as the source of energy. The results are obtained as follows. Data needed. Number of volts the Peltier generates. Results 1.08 to 2.5 volts. The number of volts the smartphone needs to achieve its fully charged state. Results 3.7 volts. Minutes or hours the smartphone needs before it gets fully charged. Results 12 hours to 21 hours. Temperature of the light bulb 37 degrees Celsius to 40 degrees Celsius.
After gathering the raw data, we were going to interpret the data. The normal charger of a certain smartphone can generate 31 volts and charge the phone from 5 to 6 hours. The thermoelectric charger, which was designed by the researchers, can generate an amount of 1.08 to 2.50 volts. The smartphone, once plugged in the USB plug of the Peltier, can be charged fully between 12 to 21 hours. However, with the same amount of voltage the smartphone needs before it can acquire the full charged battery. Moreover, with the temperature that the light bulb produces, which is at 37 degrees Celsius to 40 degrees Celsius, the Peltier could slowly generate energy from the bulb and convert it to electricity, which affected the charging of the phone, whose battery can be charged slowly too.
An experiment is conducted to test the effectivity of using thermoelectric charger using light bulb heat to charge the smartphone. The charger was effective and it worked in a certain time frame, which is 12 to 21 hours. However, compared to the usual charger, which is plugged to the sockets and connected to the electricity, the thermoelectric charger is not as effective as the usual chargers. The amount of time consumed to charge the smartphone is a way too longer than the usual charger, but as you can see, further researches can still improve this study.
For further study, the researchers recommend a higher energy releasing source than that of the light bulb. Also, design the thermoelectric charger better than what it is in this research study. The researchers also recommend using organic technology wherein it could help save the environment and advertise the preservation of our planet. We also encourage a higher heat source compared to the light bulb.